This is section 7.1, multiplication properties of exponents. So first let's review some key vocabulary, power, base, and exponent. So a power is this whole thing, for example, 3 to the 4th. 3 is the base, and 4 is the exponent. Now the exponent tells us how many times the base needs to be multiplied by itself. So in this case, it would be 3 times itself 4 times, because the base is 3 and the exponent is 4. So product of powers property is our first property that we're going to learn. So let's see if we can figure out what the rule is. So we have 2 to the second. Now we just talked about the base. The exponent tells us how many times to write that out. So it would be 2 times 2 times 2 to the 4th would be another 4 2's. So really that's 6 2's. So if I really wanted to write that as an exponent again, it would be 2 to the 6th power. So if you look at that, I have 2 to the 2nd power and 2 to the 4th power. When I multiply them together, I got 2 to the 6th power. So if you notice, what did I do with my 2 and my 4 to get 6? I added them. So the general rule for the product of powers property, a to the m times a to the n, if the bases are the same, I can just add my exponents. So I get a to the m plus n. So that's my rule for product of powers property. So let's do a couple of examples. We have 6 times n to the 3rd times 2 times n to the 7th. So we can rearrange that because of our commutative property of multiplication. Now I'm going to put the 6 and 2 together since it's all multiplication. And then we have n to the 3rd times n to the 7th. So this left part, that's just basic multiplication. 6 times 2 is 12. This part we are multiplying and we have the same base, both n. So I'm going to add my exponents. I get n to the 10th. So it's 12 n to the 10th. Let's look at this next example. I have 3p t to the 3rd times p to the 3rd t to the 4th. So again, I can rearrange 3 times, we have a p and then a p to the 3rd, and then a t to the 3rd and a t to the 4th. So I rearranged so my coefficients were together, which in this case was only 3, my p's were together, and my t's were together. Now careful, this first p has an exponent of 1. We just don't write it because it occurs so often. So when you're adding those exponents, don't forget that 1, so that you get 3p to the 4th. And then t to the 7th, because 3 plus 4 is 7. Our next rule is a power of powers property. So let's look at this, see if we can figure out the rules. So we have 3 to the 2nd to the 4th power. So I have 2 exponents. So this 4th power means I need to have 3 to the 2nd 4 times. And now we can use our previous rule. When I'm multiplying in the same base, and I can add my exponents. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So if I look at my exponents, and I have a power raised to a power 2 and 4 in this case, and I got 8, what did I do with them? Multiply. So when I have an exponent here and an exponent here, so a power raised to a power, I multiply them together. So a to the m times n. So let's look at this example. We have r to the 6th raised to the 7th, so the exponent with an exponent. I'm going to multiply. 6 times 7 is 42. Now this one, let's start on the inside. I have an exponent with an exponent. that'd be 2 to the 6th and to the 4th. So then I still have another exponent with an exponent, so I get 2 to the 24th. So you could have, at the beginning, just taken 3 times 2 times 4, because they're all exponents, raised to exponents, and gotten 2 to the 24th. Either way works. You can do one step at a time or all at once. So even if you have more than just 2 exponents, like this one, 6 and 7, you have 3, 2, and 4 in this one, it still works the same. You can multiply all those together. Alright, our last rule that we're going to learn today is power of a product property. So remember, product means multiplication. So in this case, x is getting multiplied by y. So again, x is getting multiplied by y, and so it's x times y to the 3rd. So that's telling me I'm going to have x times y 3 times. So I could group these, so I have x's 3 times and y's 3 times. That's really x to the 3rd power and y to the 3rd power. So this is kind of like the distributive property when we had a coefficient in front, except we do that with exponents. It needs to go to every single term inside. So it goes to the x and the y. So the general rule, if I have 2 terms, say a and b raised to the m power, I do a to the m power and b to the m power. Okay, so let's try an example. I have this exponent of 6 outside, so it needs to go to every single term inside. So I have a negative 2 to the 6th power. I have x that's going to get to the 6th power, and I have y to the 3rd that's going to get raised to the 6th power. So negative 2 to the 6th power is negative 2 to the negative 2 6 times. So if I have an even number of negatives, they're all going to end up being positive 64. So if you type this into your calculator and you didn't put parentheses, it's going to tell you negative 64. So just be careful with that. If you see an even exponent with a negative inside the parentheses, that should tell you it's going to be positive because you have an even number of negatives. So then we have x to the 6th, and then y, we have 2 exponents, 3 and 6, so we need to multiply those together and get 18. So 64, x to the 6th, y to the 18th. Now in this example, be careful, the negative is on the outside. So it is not getting raised to the exponent of 4, because it's not inside the parentheses that the 4 goes to. So the negative is going to stay outside. So then I have 2 to the 4th, x to the 3rd, raised to the 4th as well, y to the 2nd, also raised to the 4th. Every single term has to get that 4th exponent. So I do 2 to the 4th power, and I get 16. That negative sign is still out front. X has 2 exponents, 3 and 4, so I need to multiply those together and get 12. And y also has 2 exponents of 2 and 4, so multiply those together and get 8. Alright, so pause the video here and write down these rules. To simplify exponential expressions, all the following must be true. There's no negative exponents. The same base does not appear more than once in a product or a quotient, so we can't have multiple x's and multiple y's. They need to be combined together. No powers are raised to powers. Products or quotients can't all be raised to powers, so there shouldn't be any parentheses left. Your numerical factors in a coefficient should not have any factors other than 1. So, make sure you're reducing. Alright, the last thing is these 2 examples, so please try to pause the video and try these on your own, and then come back and see if you do them correctly. Alright, so I'm looking at example 1. I have 3xy to the 4th squared times negative 2y squared to the 3rd. So this is kind of like 2 different parts. I'm going to slowly work through each of them. So in this first one, I have an exponent of 2 on the outside, so that needs to go to each factor. So I'm going to do 3 squared, and then the x has to get squared, and the y to the 4th has to get squared. This next one, the times this part, we have negative 2y to the second and to the third. So I already have two exponents here. So to save myself a step, I know when I have an exponent and an exponent, I'm going to multiply it. So 2 times 3 is 6. So each term in this side is going to get the 6th exponent instead of doing 2 different steps. So negative 2 to the 6th and y to the 6th. So now we just have to simplify. 3 squared is 9, x squared, y, 4 times 2 is 8, times negative 2 to the 6th is 64. Again, that's a negative inside the parentheses, an even exponent, so it's going to be positive 64 y to the 6th. Now you ask yourself, am I done? Well, no, because we have two coefficients, 9 and 64. So we can multiply those together and get 576. And we also have two bases that are the same. We have y to the 8th and y to the 6th. So the x's can come down since there's only one. But the y's, we can't just leave them as two separate. We need only one group of each base. So we're multiplying. So we're going to add my exponents of 8 and 6 together on the y's and get 576 x squared y to the 14th. So same idea on this example. This first part, every term is going to get an exponent of 3. And the second part, I have two exponents again. So 2 times 2 is 4. So I'm actually going to do the fourth exponent to everything. So again, the 2 times 2 makes 4, and I did the fourth exponent to everything. So 1/2 to the third power is 1/8. Exponent with an exponent on the a, so I multiply and I get a to the 6th. Same with the b. And then we have negative 4 to the 4th. Again, that's a negative exponent, or a negative number, but it has an even exponent, so you know that it's going to be a positive number, 256, b to the 4th. So just some last things, 256 times 1/8, we need to combine that together, is 32. I only have one group of a's, so that's good, a to the 6th. I have two groups of b's, so I need to combine those together and end up with 10 of those. So that's all there is to multiplication rules of exponents.